Hello students, welcome to my channel Positron. Today's topic is a properties of matter. Dear students, to the 11th physics I have divided into two parts. First part is I have already made 10 to 11 videos, and in that part I think the recent video was based on the equations of motion and how graphically how the graph can be plotted between different parameters. Now today's topic, I am beginning the second book with the properties of matter. Dear students, you know there are the five states of a matter: solid, liquid, gas, Bose-Einstein condensation and plasma. Bose-Einstein condensation and plasma. Dear students, we are talking basically about the solid, liquid and gas. When you are studying the properties of matter, we talk generally about solid, liquid and gas, means three states of matter. If a force is applied on a matter, on a solid, let's first consider for our convenience solid material. A force is applied, then there are three possibilities. Either its volume changes, or its length changes, or its shape changes. The force which might can change either in length, either in volume, or a shape, it can change the shape, is said to be the deforming force. Dear students, as soon as this force, the applied force, deforming force is removed, body tries to regain its original condition, original status. It means as soon as you apply a force on a body, then automatically a opposite force used to begin to act in the body, and that is said to be the restoring force, and that restoring force is responsible for bringing the body back into the original status. The property by virtue of which a body regains its original status is said to be the elasticity, and such a bodies are called to be the elastic bodies, which after the removal of the force completely regains its original status. Dear students, the bodies on the basis of elasticity we can divide into two parts. One is a elastic body and another is a plastic body. Elastic body is what? A body which completely regains its original status after removal of the applied force is called to be the elastic body, and a body which cannot regain its original status after the removal of the force is said to be the plastic body. No body is completely elastic and no body is completely plastic. In fact, no body is completely elastic and no body is completely plastic. Dear students, some words you will study in this properties of matter chapter, that is a stress and strain. Dear students, these two parameters continuously number of times you will come to know about stress and strain. Actually, the strain is divided into three parts. There are the three kind of strain. What they are? One is a longitudinal strain. Number two is a volume strain. Number three is a shearing strain. And these strains are caused by the three stresses, that is said to be the longitudinal stress, number two, that is a normal stress. Normal stress causes the volume strength, and number 3, that is a shearing stress. Dear students, stress is a what? That is a force per unit area is said to be the stress. And now look here, force per unit area is pressure also, and pressure is a scalar quantity, you can say. P is equal to F upon A. The normal force acting per unit area is said to be the pressure. But dear students, stress is not a scalar quantity. It is a vector of higher rank vector. It is a higher rank vector, and such a physical quantities which are higher rank vector are said to be tensor quantity. You need not to know much about that, but you should know that stress is a vector quantity, and that is actually a tensor quantity. Tensor quantity means it is a vector of higher rank. Now, dear student, we are studying the stress and strain. The three kind of strains are: one is a longitudinal strain, and there is a volume strain. Third one is a shearing strain, and these strains are caused by these stresses. These stresses produces these strains. As longitudinal strain is caused by longitudinal stress, volume strain is caused by normal stress, and shearing strain is caused by shearing stress. Dear students, just we have discussed that a body, a solid body, you can suppose, or any body, you can suppose that it is made of number of spring structures. Like if you are considering a solid cube, then it is made of atoms, and these atoms can be supposed to be connected by a spring. And if you apply a force, then this spring would be compressed. As soon as you will remove the force, these springs will be elongated, will be stressed, will try to bring its original status, and that is why body regains the original status. This spring structure is actually just a hypothetical, just to make these studies convenient. I'm just trying to explain. Now, dear students, just I have said that on the basis of properties of matter, the body can be divided into two parts. One is a elastic body, and another is a plastic body. Elastic body is what? By application of the force, either its length changes or volume changes, or a body is deformed in the shape. And but after the removal of the force, after the removal of the applied force, body regains its original status. Then this is called to be the elastic body. And if after the removal of the force, body cannot regain its original status, then it is said to be the plastic body. But you know, no body is 100% elastic, and no body is 100% plastic. These strains are just dimensionless quantities. One thing I would like to tell you, just like to discuss with you, there is a word repeatedly, it would be told in this topic, that is within the elastic limit. We'll talk number of times about the within the elastic limit. Within the elastic limit means the limit up to which if a force is applied, then after the removal of the applied force, body regains its original status, then it is said to be with elastic limit. Elastic limit means a limit up to which you can apply a force, but after the removal of the force, body regains its original status, then it is said to be the elastic limit. And we will talk about in this chapter. This chapter is dedicated to the within the elastic limit, not beyond the elastic limit. Dear students, these properties are highly useful in engineering mechanics. When a bridge, column, pillars, these are made, then these topics are very important. These topics are taken into consideration if you are making a bridge, if you are making a heavy vehicle, like so on. So again, dear student, I have said that the strain is divided into three types: longitudinal strain, volume strain, shearing strain, and these strains are caused by longitudinal stress, normal stress, shearing stress. Stress is a what? That is a restoring force, not the applied force. Restoring force. Restoring force is what? If a force is applied in the body, then as soon as you apply a force on a body, there is a equal and opposite force is produced in the body which opposes the change in the body, and that force which is produced in the body is said to be the restoring force. And actually, in fact, the stress is not the applied force per unit area, it is the restoring force acting per unit area is said to be the stress. So I have said the strain is divided into three parts, that is longitudinal stress, volume strain, shearing strain, and these strains are caused by the stresses we applied: longitudinal stress, normal stress, and shearing stress. Dear students, longitudinal strain is what? That is a longitudinal strain, that is a change in length upon original length. Let it is a wire and it is one end is tied with the ceiling and other end you have loaded a weight, then its length will increase, right? Then the change in length divided by original length is said to be the longitudinal strain. This is small l is denoting, I have denoted small l, the change, it is representing the change in length, and capital L is representing the original length. As soon as it is, this is a wire having a uniform cross sectional area. Cross sectional area would be circular like this, and this is from here to here, it is a uniform wire, and here it is our load is hanged with this. Then if load is hanged, then its length will increase. Let the change in length, increase in length is small l, whereas the original length was capital L. Then longitudinal stress will be small l divided by capital L. Dear student, now longitudinal stress is what? Longitudinal stress, I have said that stress is a restoring force per unit area. That is not a applied force divided by area. So restoring, as soon as this weight is hanged, then there is its length will change, but after the removal of this hanged weight, the wire will try to regain its original status. It means as soon as you have applied the weight, there is a force produced in the wire that opposes the change in length, that opposes the increment in the length, and that force is a restoring force, and this very force divided by area A is said to be the longitudinal stress, or you can say F upon A is pi r square, where r is the r is a radii of wire, radii of circular cross section of wire. So longitudinal stress is equal to restoring force, that is actually equal and opposite to the applied weight, divided by cross sectional area pi r square. R is the if this is the wire, then this is a cross section and r is the radii of this cross section. So force divided by area is equal to the longitudinal stress. Now let's move ahead. The second one is a, dear students, second one is a normal stress, that causes the volume strain. Volume strain is what? Now look here. Volume strain is what? Volume strain is the change in length divided by original volume. The change in length divided by original volume, that is said to be the volume strain. Volume strain is what? The change in length divided by original volume, and that is said to be the volume strain. Like this is a body and a very heavy pressure of force is applied. And volume strain is caused by normal stress. Normal stress is what? Dear student, normal stress is equal to force upon area. That is, dear students, you know that pressure is defined as a normal force acting per unit area is said to be the pressure. And in the pressure, there is a direction of the direction is predefined. That is why it is a scalar. P is equal to normal force acting per unit area. It is not the force per unit area. When you decide, when you define pressure, then you always say the normal force acting per unit area is said to be the pressure. Normal stress, I have said just before that, actually stress is not the pressure. There is a big difference between the stress and pressure. Pressure is a scalar quantity, but stress is a vector quantity and it is a vector of higher rank that is said to be the tensor. But you can say this normal stress is very close to the pressure. In nature, I mean to say. Like you have considered a cubite, it is iron, steel or anyone, and you applied a force this, then it will try to compress. And if it will try to compress, it means its volume is going to be changed. So volume is it produces the normal stress produces the volume strain, that is change in volume divided by capital V original volume. Small v is representing the change in volume and capital V is representing the volume, original volume. And normal stress is a force per unit area is what? Let you are watching my video sitting in a room. There is a ceiling, and on the ceiling a force is applied. Normal force is applied. Then area of that ceiling you have to consider. So force upon area. Force is a normal force, and area is what? Area is the ceiling or area of the upper face of the cuboid on which the force is acting. Now, third one is, dear student, the two stress and strains we have discussed. And third one is a sharing stress and sharing strain. Sharing strain is the what? That is a force which changes the shape of the body. That is said to be the deforming force. And shape of this strain is a sharing strain. The strain produced because of change in the shape of body is said to be a sharing strain, and this sharing strain is produced by sharing stress. Now, dear student, let it is a room in which you are sitting and watching my videos, okay, enjoying my videos. And dear student, this room has the 6 faces. I'm looking your room from outside. Okay, I mean it is actually 3D, but I'm just taking the outer surface of the room. This is right. If on the ceiling a force is applied in this way, this is a tangential force. This is a room, that is a ceiling. On the ceiling, I'm applying a tangential force. Then what happened? Let it is A, it is B, it is C, it is D. Now what happens? This ceiling will move away. Okay, will move ahead, will move further, and A will reach to A dash, and similarly B will reach to B dash. And this angle, let theta it is. It is a angle of shear or shearing strain. Let it is a cube whose each side is a capital L. Then small l is the change in the length. That is A has gone to A dash. Means A has been displaced by length small l. Now dear student, the shearing strain is what I have said. Shearing strain is that is equal to theta. If angle is a very small, then theta equal to sine theta approximately equal to tan theta, and tan theta is equal to change in this is perpendicular upon base, small l upon capital L. You can write what I have said, that just you are watching my video sitting in a room, and at the roof of that, at the ceiling of that room, I have applied a tangential force. Because of that force, your ceiling has moved a bit, and this is representing, AB is representing actually the ceiling. Point A goes to A dash, B goes to B dash, and now the angle here, this wall will inclined in this way. This wall will be displaced in this way. So this wall AD has been displaced by an angle theta, and this angle is said to be shearing strain. And shearing strain, if theta is a very small, then you can say, according to your convenience, you can suppose it to be sine theta, because sine theta is equal to theta, or tan theta is also equal to theta if it is very small. So theta I am considering equal to tan theta, that is equal to perpendicular upon base, small l upon capital L. Dear student, this strain is caused by shearing stress. These different strains are caused by specific stresses, and this strain is caused by shearing stress. Shearing stress is what? I have said that the room in which you are sitting and watching my video, at the surface, at the top surface, at the ceiling, at the roof of that room, I have applied a tangential force, right? So the shearing stress is always, that is force divided by area, that is a shearing stress is equal to tangential force divided by area of the ceiling where you have applied the tangential force, and that is F upon A. Shearing stress is equal to F upon A. F is the tangential force that you have applied on the roof, and A is the area, that is the area of the roof on which tangential force has been applied, and shearing strain is equal to small l upon capital L. Dear students, again I am repeating my words. The three kind of strains are: strain is what? Within the elastic limit, that is longitudinal strain is change in length divided by original length. Volume strain, change in volume within the elastic limit, change in volume divided by original volume. Shearing strain, that is the angle by which a body has shear. Here actually it is a force which deforms the body, which changes the shape of the body, is said to be the deforming force. Now this force is a deforming force, and body, the wall AD has been sheared by an angle theta. How it is sheared? Just a force I have applied on the top of your room, on the roof of your room, and because of that force, your ceiling has been displaced away. A has gone to A dash, B has gone to B dash. This angle is a theta. For our convenience, actually the shearing strain is a theta. The angle by which a body has been sheared, that is theta. But if theta is a very small, then you can suppose theta equals to sine theta or equals to tan theta. But we are convenient here if we suppose tan theta, because the two parameters we know. So tan theta is equal to perpendicular upon base small l upon capital L. And this kind of shearing strain has been produced by shearing stress. Shearing stress is what? The tangential force divided by area of the roof of the ceiling on which the tangential force has been applied. So force divided by area of the roof. Okay, that is. So this was the three kind of stresses that produces the three kind of strain. Now dear students, next topic is behavior of wire by increasing the load. Let's consider a wire on which a load is hanged. You are just increasing that load. Then what would be relation between the stress and strain? Okay. Dear student, before going this topic, there is a very important small topic, that is Hooke's law. First we should study the Hooke's law. then we should come to this topic. Okay? Hooke's law is what? Within the elastic limit, stress is proportional to strain. That is said to be the Hooke's law. Within the elastic limit, stress is proportional to strain, and that is said to be the Hooke's law. So, within the elastic limit, stress is proportional to strain, and this is said to be the Hooke's law. Dear student, stress is equal to some constant multiplied by strain. In order to remove the proportionality, you have to multiply by a constant. Or stress upon strain is equal to constant, and this constant is actually elastic constant. Dear student, how you can define the Hooke's law? Within the elastic limit, ratio of stress and strain. Stress, there are the three kind of strains which are caused by three kind of stresses. So the ratio of stress and strain is equal to a constant, and that constant is actually the elastic constant. Okay, so this is the Hooke's law. Stress is proportional to strain. Stress, when in order to remove the proportionality, I have multiplied by a constant. So ratio of stress and strain is equal to constant, and that constant is some elastic constant. Dear student, so how we can define Hooke's law? Within the elastic limit, ratio of stress and strain is equal to a constant, and that constant is said to be the elastic constant. Now come to our topic, that is it. The behavior of wire by increasing the load. Dear students, I am telling you a very interesting fact, that let the city in which you live, there is a bridge, and that was made 100 years before in British period. Dear students, in the language of mechanics, it is said that every material has a tension, and that tension remains for some specific year, and after that years it loses its tension, and now it becomes weak, and if a load is given, it would be broken. So after the span of 100 years, your bridge has expired. It's a time span is not expired, right? It means after that, no load can be given, no car can run, no truck, no vehicle, no heavy vehicle can run through that bridge. Why is it so? It is simply because if you are continuously applying the stress, then what happens? Because of elasticity, the two molecules begin to move away as soon as the stress is applied, and after the removal of stress, I mean after when the vehicle has just left the bridge, then molecules come closer to each other, and then that material becomes again strong. But what happens repeatedly? Every day, thousands of cars, thousands of heavy vehicles are passing through that bridge. Then what happens? Gone with the time, yet molecules are departed away because of stress, but as soon as the vehicle has gone, they do not completely come to their original status. It means material has lost its tension. It means material has become the weak. And there is something very interesting, that if the scrap is taken, what happens to that scrap of the bridge? You cannot use it in heavy vehicle. You use how you can use? You can use to make the home items you can make, which does not require much load. But you cannot make another with that. Even after the recycling, the material do not gain its tension. Even after the recycling, the molecules do not come to close. It means if repeatedly stress is applied, weight is given, then After some years, the molecules will be permanently displaced and they cannot be brought back even after the recycle. So, the scrap of heavy bridges cannot again be used in making heavy bridges or heavy vehicles or any engine like thing. It is used in making the spoons, in making plates, steel plates like this. Okay, so dear student, behavior of wire by increasing the load. How a wire behaves if stress is increased, if the load is increased. I'm plotting just a graph between stress and strain. It is from O to P. Actually, you can say it. This graph is straight line. Straight line means it is following the Hooke's law. Means stress is proportional to strain. Okay, it means it is within the elastic limit. Stress is proportional to strain. It is following the Hooke's law. Okay, but dear student, next is it is P dash. Actually, graph is not a straight line. It means it is not following the Hooke's law. Stress is not proportional to strain. But after the removal of the force, body regains its original status. Dear student, after the removal of the force, body may regain its original status, but it is not sure that it will follow the Hooke's law. Hooke's law means stress is proportional to strain. Means if you are loading, just increasing the load in the same way, in the same manner, in the same proportional, the strain length is increasing. But a time may come after it is elastic limit. Hooke's law followed. You can say it's a following Hooke's law. Means from O to P, graph is a straight line, means stress is proportional to strain. Okay, and it is also within the elastic limit. From P to P dash, what happens that you, as soon as you increases the load, you increases the stress, but strain is not increasing in that proportion. Means stress is not proportional to strain. Means from P to P dash, it is not following the Hooke's law, but it is within the elastic limit. Means by the application of the force, by the removal of the force, body regains its original status. So what I have to say that from P to P dash, yet body regains its original status after the removal of the force, but stress is not proportional to strain. It means it is not following the Hooke's law. Now, dear student, further P dash to Y. This is Y is said to be the yield point. Means if you have increased the load, you are increasing the load, then further what happens? That is Y is said to be the yield line. Means the molecules of the wire will be displaced because there is a elongation, there is a stretch in the wire. Molecules are displaced, but after the removal of the force, they will not come back. There will be some displacement left after the removal of the force. The wire will not regain its original status. There will be some displacement, relative displacement will be left in the wire, and that is said the wire is a permanent set. Permanent set means it is beyond the elastic limit. There is no means of Hooke's law because it is beyond the elastic limit, and Hooke's law is still further within the elastic limit. But one thing, between P dash and Y, yet there is a permanent displacement. Wire is permanently set. But one thing is active between P dash and Y, that wire is a uniform. Wire is a uniform. Wire is a uniform. I mean, From here to here, the cross-sectional area of wire is the same. There is no change in cross-sectional area of wire. It is not that if you have hang the weight here and wire becomes thin here. No, not at all. And further why there should be, it is called B, breaking stress. This is said to be breaking stress. And it is breaking point. Dear student, this is a breaking stress. Breaking stress means at this point, if you have increased the stress up to this point, now wire is bound to be broken. Nothing can stop. Even if you stress decrease, once you have reached that optimum value of stress required to break the wire, that is said to be the breaking stress. Even after the removal, if you just try to decrease the breaking stress, even you cannot stop from breaking the wire. Wire has to be broken at this point. If once the stress has reached up to this point, even after the removal of the stress, wire is bound to be broken. It is compelled to be broken despite you are just decreasing the stress. So it is said to be the breaking stress. Now in the case of permanent set, what I have said that the wire is a uniform cross-sectional area from here to here of wire was uniform, but here wire begin to form neck. Like our neck, this is our lower part of the body and it has a cross-sectional area just constrained. So similarly, at this point, the wire begin, the point where the load is hang, at around this point, wire begin to thin and it forms a neck-like structure, and now wire becomes so weak that it is bound to be broken despite the breaking stress or the stress is decreased. So it was a behavior of wire by increasing the load. I have tried to explain the best I can do. But if there is a problem, dear students, do ask to me, comment to me. Okay. In next videos, I will discuss the elastic constants, their relations, how these elastic constants can be derived. Dear students, I'm trying to do my best. If you think that these videos are going to be beneficial in your study, if you are preparing for ITJ medical NEET like exams, okay, then if you think that my videos are working good to you, then it's my request to you, please and please share, comment and subscribe my videos. I'll also meet you in next video. Till then, bye.